My name is Kaylee Mastriani. I'm the Director of Operations for DPX Technologies. And I'm simply hosting this webinar today about serum sample preparation. Nick Chestara is our presenter today. He's a technical sales support for DPX. He's been with us for over 3 years now and has extensive experience in clinical laboratories working with all sorts of matrices and analytes using LC-MS analysis. So without further ado, Nick, I'm going to let you get started.
Well, thank you, Kaylee. Thank you very much. And thank you everyone joining us today for our final webinar of our April webinar series. Here, as we start every webinar, our little milestone timeline. Again, I'd like to point out at the very end, 2020, DPX has filed for 2 different patents and a new collaboration with Millipore Sigma Sapelco. So getting started here, our strengths here at DPX are automated sample preparation, product lines. We have INTip SBE products that automate bind wash elute procedures, as well as chemical filtration procedures using dispersive pipette extraction technology. Our novel INTip filtration product lines are made possible by our tip-on-tip technology. And finally, our highly anticipated, our newest technology is the INTip size exclusion chromatography product line. I won't be able to go into much detail for this product in today's webinar. But please reach out for more information. We're extremely excited to launch this new automated solution for size exclusion. For today's presentation, our webinar will be on a discussion of INTip sample preparation for both blood and serum assays. And to do so, I'm going to go over 3 different strategies, 3 different approaches to automating this application. The first strategy will be a diluted serum, followed by MicroElution SPE. The second strategy is our soft crash using zinc sulfate, followed by tip-on-tip technology. And then finally, the third strategy is a full protein precipitation, which is our tip-on-tip technology, followed by additional cleanup with XTR tips, DPX extraction tips. Now I do have here at the bottom dry blood spot analysis, automating that process. I don't really have much in the webinar on this topic, but if you are interested, please contact us, reach out, and we'll be happy to help you with automating dried blood spot. All right, so jumping right in, let's look at the first strategy here on this slide. So we're going to dilute the serum. We are diluting the serum so we can aspirate and dispense the sample into a DPX XTR tip. In this application, we're going to use our patented MicroElution product. It contains INTip chemistries. It's ideal application for small volumes of sample. If you are limited to the amount of blood or serum or plasma, this would be something to look at. The process involves a bind wash elute extraction protocol, and that can be completely automated using the DPX MicroElution extraction tip using an automated robot liquid handler. The liquid handler will perform all of the aspiration and dispensing steps, the pipetting steps, as the robot will simply take the DPX XTR tip and it will aspirate and dispense the serum sample that we've diluted, and it will disperse the resin throughout the sample, binding the analytes of interest inside the tip. The robot will continue and it will move to aspirate and dispense a wash solution, and continuing on to aspirate and dispense the elution solvent to collect a clean sample ready for analysis on the LC-MS. This approach is incredibly fast. You can perform 96 samples at once. It's ideal for small molecule analysis, provides a very clean sample with minimal solvent usage. It's designed to avoid dry down evaporation steps where that's possible. And the tip is available in 300 microliter hardware size. Again, this is really focused on using very small amounts of samples as far as the serum aliquot or the plasma aliquot goes. We do have a range of 10 microliters to about 200 microliters for this application. All right, so let's take a closer look at the MicroElution XTR tip, the extraction tip. The proprietary design utilizes a unique low retention frit, which allows us for minimal loss, and we can use elution volumes as low as 25 microliters. And that way we can really get a concentration effect without the use of solvent evaporation. So the sorbents are available, have a particle size greater than 50 microns for each of the chemistries listed here. We have our weak anion exchange, we have our weak cation exchange, strong cation exchange, reverse phase, and our HLB sorbents. This tip can be manufactured in a Hamilton 300 microliter as well as a Integra style 300 microliter tip. Let's take a look at a comprehensive analysis for therapeutic drugs using plasma samples. In this case, we are doing a comprehensive style approach. So we are going to use our strong cation exchange resin. We are going to dilute our plasma 1:1 with 2% formic acid and water, and simply aspirate and dispense using our MicroElution tip. And again, this is using a liquid handler to do the pipetting steps. After we bind the analytes to the resin, we will wash off the interference prior to eluting our analytes into a clean well or test tube ready for injection. This slide here, I have some results. Hopefully everyone can see it. The graph here shows the recoveries of a couple of the analytes in a comprehensive panel. For example, using this procedure, our elution volume is 25 microliters. Sorry for the typo there. So as you can see with the analytes listed here, all the analytes are about 70% recovery using just one elution of 25 microliters. The remaining recovery is achieved by doing a second round of a 25 microliter injection. This innovative INTip solution is really ideal for the small volumes. As I've mentioned, it's very customizable. We have a variety of sorbents and chemistries based on obviously your application and target analytes. We're really simplifying this method, we're automating it, and it's very effective for high throughput analysis. All right, so back to this slide, we're going to look at strategy 2 now. If you have an analyte of interest such as vitamin D or something that's very highly protein bound, you might rather look at strategy 2 or 3 for your automated workflow. So strategy 2 is going to incorporate zinc sulfate in what we call a soft crash. We spike the zinc sulfate into the serum or blood sample prior to the addition of the extraction solvent, methanol or acetonitrile, for further protein coagulation. Using DPX products, we won't be needing offline vortex or offline centrifugation. We can keep everything on the deck of a Hamilton liquid handler for our tip-on-tip filtration process. Now the benefits here works really well for larger compounds and slightly more hydrophobic analytes. Certainly has benefits of better recovery for certain analytes, as well as improved matrix effect, which again is analyte dependent. Let's take a look at this workflow. We are going to first, let's do 100 microliters of whole blood at our internal standard, and using a HHS system, a Hamilton heater shaker, we can incubate the internal standard for a couple minutes. Then the liquid handler will come in and add the zinc sulfate, which is 25 microliters of a aqueous zinc sulfate solution. It shakes for 30 seconds to do that soft crash. Then we come in with our extraction solvent. We're adding 250 microliters of acetonitrile. Shake for 60 seconds. Then coming back in with a wide bore tip, we're going to aspirate that supernatant. And then we're going to do our tip-on-tip technology. We're going to insert a filtration tip and attach it to the wide bore tip and dispense through the filter, collecting the precipitation on the filter and allowing a clean filtrate to pass through and be collected, containing our target analytes. So let's look at the video here. I have a video of a Hamilton Nimbus. Right now it is picking up the zinc sulfate, and it's going to come over here. Let me pause it real quick. So just showing you this setup here, we have some, these are called shell vials. They're like shorter test tubes, so we can use the Hamilton for this application. We have a custom shell vial block here, and we are going to be pipetting onto the HHS system, which you can kind of see in the back. And we just add the zinc sulfate. So I'll start it up again, and you will see we're gonna restack those tips because we know that they're a hot commodity these days. So we're gonna shake that for a little while. Then we will now add our extraction solvent. This will be the acetonitrile. Dispense that. We're not going to throw those tips away. We're going to hold on to them as we shake. This is doing the protein precipitation, mimicking the offline vortexing. Now we're going to go back in and aspirate the sample into the tip. That's the crash sample. We're going to get our tip-on-tip filtration tip and dispense into our collection of shell vials here. So we've now just dispensed our crash solvent through the filter of our filtration tip, and now we are ready for downstream analysis. Taking a look here, we have a testosterone application using this exact procedure. We have presented this at SOFT before. We have a 6500 plus LCMS system, and we are going to be doing a testosterone application and comparing it with, we did a study with Stanford Healthcare for this project. So here, a closer look at the tip-on-tip. We have the wide bore conductive tip at the top. In the video, we used a clear tip so you could actually see a little bit better. Now, the bottom tip is the filtration tip, and it is held together with an airtight hold with our proprietary gasket there. Now, at the bottom, we have our filter options. We have a low porosity filter, a single phase filter, and a dual phase filter, which is shown here. Okay, so for the testosterone application, it's slightly different than the whole blood comprehensive panel. This is going to use 75 microliters of serum. We're going to add 10 microliters of internal standard. And for testosterone, we really want to let it incubate with the internal standard for at least 20 minutes, giving that a good shake, because that's a very significant part of the protocol for hormones. Then we'll come in with our zinc sulfate. We'll shake for a little bit and do that soft crash, as I mentioned, before coming in with the extraction solvent, acetonitrile. We aspirate that precipitated solution. The Hamilton robot will grab the filtration tip, and then we will dispense to collect our clean filtrate. Going back to the comprehensive panel, here is a table. This is a graph, I'm sorry. The top are in blue and gray is our recoveries of each of the analytes below. Obviously, it's just a handful of analytes here being presented, but you can see the blue is recovery without zinc sulfate, and the gray is recovery with zinc sulfate. And then on the bottom in the orange and yellow, we are looking at matrix effect with and without zinc sulfate. So you can see it does depend on the analyte. For example, here you can see methadone and some of the benzos really improves the matrix effect there, as well as recovery. This next slide here is a graph showing, again, a comprehensive panel, but we are comparing, I'm not sure if you can see the comparison of manual centrifugation versus the tip-on-tip filtration. All right, moving on, we are going to look at strategy 3 now. Strategy 3 is a full protein precipitation. Now, this does provide a little bit more potential loss of analyte when we do a full protein precipitation. We are just going to crash and filter on the robot. And then we were going to come in with another an XTR tip to provide the cleanest sample using full automation. We have a couple options here. So after the tip-on-tip technology, filtering the crash solvent, we're going to come in with our XTR tip, either the Wax S, which is a salt-assisted liquid-liquid extraction. I presented this topic last week during the webinar. But we also have another option, our hybrid SPE and a dispersive pipette will remove any phospholipids present that really interfere with accuracy on the LCMS side of things. All right, taking a closer look, here is a procedure using the Wax S, 100 microliters of serum. We're going to add the internal standard. We're going to add the extraction solvent to make the protein precipitation. We are going to dispense through the filter using our tip-on-tip technology. And then to that extract, the filtrate, we are going to transfer it to do our Wax S procedure. Our Wax S procedure, again, it's just an aspirate and dispense. We're going to do it 3 times, and we're going to salt out the aqueous layer, driving all the analytes into the organic layer, and it does create a separation when we increase the ionic strength of the aqueous. This way, we really keep all the analytes of interest in solution the entire time. We're not going to be binding it to the resin. We're going to be just creating this liquid-liquid extraction on the deck. All right, the next is the hybrid SPE. So phospholipids, as I mentioned, can cause ion suppression, impacting the accuracy of the LCMS. So in an entirely organic environment, we can use the hybrid SPE to remove phospholipids. This is a really great product, and here are some options for this. We have 30 milligram tips if you're using 30 to 100 microliters of serum, and 50 milligram dispersive tips as well if you have above 100 microliters of sample. Generic workflow using the hybrid SPE resin. We'll start off with 200 microliters of serum. We're going to add the internal standard extraction solvent and 1% formic acid for the protein precipitation step. When we have our clean filtrate, we are come in with the hybrid SPE tip, much like we did with the Wax S tip. Again, it's just an aspirate and dispense of that final filtrate after the crash step, and we will, in a completely, almost entirely organic environment, we are going to aspirate and dispense and remove the phospholipids from the sample. And here, if you need to dry down a recon for sensitivity purposes, you would do so after removing the phospholipids. This slide here, we are looking at a vitamin D panel. The picture shown above, we have 1 mil wide bore tips. These are 1 mil clear Hamilton tips, and it's going to add acetonitrile to a whole blood sample. Instead of using the Hamilton heater shaker, we are going to aspirate and dispense to create the same effect you would as vortexing. So aspirating up and down several times to cause that precipitation. Then we could come in with the tip on tip. We're not using the zinc sulfate in this case. We're just doing the whole blood crash and then filter using the tip on tip technology. Here are some chromatograms of the vitamin D analytes. Really good data here. I cannot take credit for this. This was done by my colleague, but just really good numbers here. You know, we're getting over 90% extraction recovery of vitamin D metabolites. This one here has some stats on the testosterone application. This one I can take some credit for. I've worked on this for some time now. A really great method here we have for testosterone. We've presented in soft and MSACL before on this. All right, so in conclusion here, we have our different matrix, serum, blood, as well as plasma. Using our target analytes here, if we want to do testosterone, we have some options. Again, I just want to focus on what we're looking at the end, the automation. Very fast, very effective, and this is for 96 samples at a time. So we can do under 5 minutes for testosterone, comprehensive blood panel using our low porosity filtration tips and our tip on tip technology. You know, we're under 2 minutes extraction time for that to you know, basically start to finish for this whole process. Our serum vitamin D panel using a dual phase filtration tip followed by a wax S if you want to add a little bit of a concentration effect and further cleanup post filtration. Again, very fast, very effective, and our hybrid SBE, if we're looking at larger sample volume, that too is very amenable to the automation and very fast, effective in just under 5 minutes. So if you have any serum applications or blood applications, if you have one target analyte or a comprehensive panel, DPX can be a solution and a solution that is user-friendly. So friendly, in fact, the user can actually step back and watch hands-free as the extraction is carried out by DPX products using automation in just a matter of minutes. All right, here we have our team, our DPX team here, the young Bill Brewer. He is our CSO and CEO. The cornerstone of DPX, Kaylee Mastriani. And then we have our East Coast and West Coast sales directors, Bill and John. Dr. Fitz here, our molecular biologist. And a big thank you to Carmen, our brand manager, who has really put this whole webinar series together for us very well. Special thanks to her. And then, of course, myself. So thank you, everyone, for joining us. I think we'll take some questions.
Thank you so much, Nick. That was awesome.
Thank you.
Anybody have any questions? If you don't want to unmute, you can absolutely type your question into the chat box and I can speak it out to Nick. We can try to get those answers. Looks like we've got one coming in. What are the advantages, if any, over the Stanford method, Nick? I believe he's referring to your testosterone protocol.
What is the advantage over the Stanford method?
Correct.
Doing which? I'm sorry, I don't.
Testosterone protein precipitation and filtration versus
the Stanford method.
method, correct?
That is actually a great question. So the Stanford method was a labor-intensive liquid extraction. It takes them 6 hours, or it did take them 6 hours to perform. And with our automated testosterone application, as you can see, post the internal standard incubation step, it's just a matter of minutes to do 96 samples. So fast, effective, robust, and of course, fully automated. That would be the best attribute there would be just your time savings, FTE time.
Great. And was it less sample volume too? Using less internal standard and reducing those costs is always a nice plus.
That's correct. Reducing the sample volume from 200 down to 75. So we could also reduce internal standard cost usage as well as the solvents.
Awesome. Any other questions? Okay, well, if you think of any questions after this webinar, feel free to reach out to the email address currently listed on your screen. Carmen, our brand manager, will be in touch with a link to this entire presentation along with the recording. And certainly if you have any colleagues that are interested, feel free to forward the presentation on to them. Further, we help clients all the time with how to convert their current methodology over to a more low volume, fast automated approach. So we've taken many clients from a large sample volume liquid extraction protocol over to a low volume automated approach, regardless of the matrix and analyte combination. So if you feel like that applies to you and you'd like to switch it up and try something different, please reach out to us and we would be happy to talk you through how DPX could improve your workflows in the laboratory. Okay, and with that, I believe we will conclude. Thank you again, Nick. We really appreciate your time today, and thank you everyone for attending. We will be in touch.